And welcome back to 3.3 Notes, where we're discussing unit conversions. And in this next example, we're going to be talking about how to convert more complex units. Just taking a look at this little paragraph right here, it just says that many measurements are expressed as a ratio of two units. Speed is measured in miles per hour, or sometimes we use kilometers per hour, or sometimes we use meters per second. Density is another quantity that's measured as a complex ratio, where you have it either in grams per cubic centimeter or kilograms per meter cubed. But to change these complex units, you simply have to change each unit just one at a time. So we're not doing anything new, you're just doing it in multiple steps. So here's your example. We're on example number 6 now. It says that Usain Bolt, the Jamaican sprinter, ran 100 meters in 9.58 seconds. He did that in the last Olympics. Calculate his average speed in meters per second and in miles per hour. So I'm going to go ahead and scroll down just a little bit, give myself a little more room. And again, the first thing that you want to do is look at what units that you're trying to achieve. Well, we're trying to achieve first meters per second. Well, the nice thing about this is when you look at the question, we already have meters and we already have seconds. So you can align the units so that they match up with your final unit. So we're going to simply put our 100 meters over our 9.58 seconds. And now you have meters over seconds. Your answer needs to be in meters over seconds. So now you're ready to calculate. Just that easy. You don't have to use any equation that tells you how to calculate velocity or speed, although you can. But if you simply plug in your units into the proper spot, you can get the correct answer. So if you take 100 divided by 9.58, he was running 10.438 meters per second. Now, as it's written right here, you only have 1 sig fig on top and 3 sig figs on the bottom. I'm going to change this just slightly because I want to do this slightly different. I'm going to actually put a decimal in there so that now we have 3 sig figs on top, 3 sig figs on the bottom, so therefore our answer should have 3 sig figs. So we have 10.4 meters per second as his average velocity. Now that's not his top speed, that's his average speed over the entire course of the track. Now what we're going to do is we're going to convert this 10.4 meters per second, and we're going to convert that into miles per hour. So how do you do that? Well, you have to convert meters into miles. I'm going to put this way over on the other side. And you have to convert seconds into hours. It doesn't matter which order you do it, it just has to both get done. So let's go ahead and convert meters into miles first. We know that there are 1,000 kilometers, 1,000 meters, scratch that part out, in 1 kilometer. So therefore the meters divide out top and bottom. And now we need to change kilometers into miles, taking a look at our conversion sheets that you should have out at this point. We know that 1 kilometer is the same as 0.62137 miles. So the kilometers divide out top and bottom, and now we're in miles on the top, or in the numerator. And now all we need to do is change our seconds into hours. So we know that we have 60 seconds in 1 minute, so that the seconds divide out top and bottom. Notice that they do not have to be next to each other. As long as you have one in the numerator and one in the denominator, it works out. And we also know that we have 60 minutes in 1 hour, so that the minutes divide out top and bottom. So now you have miles on top, you have hours on the bottom, and you're ready to calculate. So if we take 10.4 divided by 1,000 times 0.62137 times 60 times 60, it looks like we're getting 23.264 miles per hour, or if you round to the proper number of sig figs, the first term has 3 sig figs. The second term is an exact definition, so that we don't have to worry about. The third term has 5 sig figs, and then the last 2 are exact definitions. So you have 3 sig figs and 5 sig figs, so we have to go with a 3, which would be the least, which means we'll keep the 2, the 3, the 2, and then the 6 will make this 2 round up to a 3. So it looks like we have 23.3 miles per hour. Now that was his average speed. That was not his top speed. I think his top speed was over 30 miles per hour, but I'd have to double check that. But his average speed over the course of that track is 23.3 miles per hour. That is really, really moving. All right. So taking a look at that, I hope you see that doing complex units is really nothing different than doing a simple unit. You simply have to do them one at a time. All right, scrolling down, I think we have enough time to do this next one. Number 7 says the density of gold is 19.32 grams per cubic centimeters. How many pounds would 1 gallon of gold weigh? So, write down what you know. We know that gold has a density of 19.32 grams over cubic centimeters. And what you're looking for is pounds. So I'm going to put pounds way over to the other side. Now this is more than just a conversion. This is actually a question where you're going to have to eliminate some units. Grams is on top, and you want to find pounds, so they're both units of mass or force, so that's going to work out okay for us. The grams per cubic centimeter we're going to need to get rid of, because it's not anywhere in the answer units. But we don't have cubic centimeters to cancel out. We have gallons. So what you need to do is you need to change cubic centimeters into gallons first, and then cancel it out. So cubic centimeters. Well, as it turns out, 1 cubic centimeter is the same as 1 milliliter. So those cancel out. We know that we have 1,000 milliliters in 1 liter. So the milliliters divide out. Taking a look at the conversion chart, we know that 1 gallon is the same as 3.7854 liters. So the liters divide out. And now what you can do is you can take the quantity, as it turns out only 1 gallon, you can multiply this thing by 1 gallon. Now again, this 1 gallon here comes from the problem. If it happened to say 2 gallons, then you would have changed this to a 2 gallons. You can multiply or divide by anything that's in the question. So that effectively gets rid of our gallons for us, and nothing is in the denominator, which is what we want to have. And then the last thing that we need to do is we need to change the grams into pounds, because that's what we're looking to get into. And as it turns out, looking at the conversion sheet that I have in front of me, 1 pound is the same as 453.59 grams. So the grams way over here divided out with the grams way down here, and now we're left with pounds, we're looking for pounds, and we're ready to do the calculation. So it's going to be 19.32 times 1 divided by 1 times 1,000 times 3.7854 times 1 divided by 453.59, and I'm getting 161 pounds. 161.233 pounds. And if you take a look at our sig figs, we have 4 sig figs here. We have perfect definitions. This is 5 sig figs. This is 5 sig figs. And so we're going to have to go with 4. So it's going to be 161.2 pounds. That's how much a 1 gallon jug of pure gold would weigh. Gold is a very dense, very heavy metal. Filling up a milk jug with gold would weigh 161 plus pounds. That's tremendous. Hopefully between these two examples you get the gist of how you're going to do conversions and calculations using complex units. Remember, I would be doing the calculations on your own as I'm doing them on these podcasts, just so you can double check the work and see how you type these things into the calculator. Okay? Scrolling down, I believe that takes care of section 3.3.